Hi guys, welcome to week 3 of this online stuff. Um, you'll see this week, I might have made a post about it, but sort of cutting back on the amount of material and assignments and all for this week. For a few reasons, but one being this particular lesson is a little bit intense, and I figured you could take your time on it, rewatch the video, do whatever works for you. I don't know exactly how long this video is going to go, but it's going to basically apply to 2 days worth of lessons, and then and then I'll just do one mastery for it and one homework, as you'll see. So anyway, here's your bell ringer from last week. It says, where is it undefined? Okay, if that is a little bit confusing to you, that's the same as asking for the excluded values. So, okay. If you did it properly, you should have factored the denominator to x minus 7 and x plus 2. Set those equal to 0 and solve. You get positive 7 and negative 2. Okay. We're going to sort of use that a little bit today. So we're going back to talking about asymptotes, which I believe we started talking about last week. Everything's kind of mixed up in my head right now with my classes, but and you can hear my cat out there. So asymptotes, if you're looking at this picture, are basically these dotted lines that you're seeing on here. Also, I'll note that if you look under this week's materials, you'll also see a Chapter 8 cheat sheet, and it's going to be helpful to have that up so that you don't have to keep running back and forth, because you're going to need to reference these pictures quite a bit. So yeah, if you're looking at those examples here, these dotted lines are vertical and horizontal asymptotes. And you can sort of see why that's the case. It basically dictates what the function or what the curve looks like. It sort of guides it along the way in a sense. One of the definitions that you hear, and I might have mentioned this last week and then said that it's not a very rigorous definition, is that an asymptote is basically a line that the curve is never going to touch or never going to intersect. That's not exactly true. It could go through it, but basically the dotted line, which again is the asymptote, and the curve basically get closer and closer and closer as the function approaches infinity, which is what we call that. It's more of a calculus concept. You'll understand it more when you get to that point. But in any case, that's sort of what the graph looks like. Obviously, because we're unable to graph, we're kind of more focused on just looking at these and finding them as opposed to actually graphing them or seeing what they look like visually. So let's look at some of the stuff up top here. So the vertical asymptote's easy. It is whenever it says b of x equals 0, and then if you look up top, it says f of x equals a of x over b of x. So it's basically whenever your denominator is 0. And that's why we were finding excluded values last week, for that reason. So that's easy. Horizontal asymptote is different, okay? And there's basically 3 different rules, because there's 3 different possibilities. My cat's paws are coming under the door. Okay. So if a of x, if the numerator is greater than the degree, if the degree of a of x, the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So quick reminder, what does degree mean? So an example of that first possibility would be if it said f of x equals, let's say, x cubed plus 2 over x minus 1. The degree of the numerator is 3, because that's the highest exponent you see, whereas the degree of the denominator is just 1, because that's the exponent down there. So since the degree of the numerator in that case is greater than the degree of the denominator, as it says, there is no horizontal asymptote. Okay, so that's your first possibility. Second possibility, if the degree of a of x is less than the degree of b of x, the horizontal asymptote is the line y equals 0. Okay, so let's just say I take the one I just had. I don't remember exactly what I had. X cubed plus whatever it was. I don't remember. 5. It doesn't really matter. So in this case, the degree of the numerator is less than the degree of the denominator. So then when we get to writing our vertical and horizontal asymptotes, you would just say a horizontal asymptote is y equals 0. Okay? And then the third possibility is basically if their degrees are equal, okay, then you find the horizontal asymptote by putting their leading coefficients over one another in a fraction. So an example of that would be, let's say we have f of x equals x cubed plus, no, let's put a coefficient there. Let's say it equals 4x cubed plus 1 over 3x cubed minus 5. So because these are both degree 3, we're going to take their leading coefficients, which are 4 and 3, and we're going to say our horizontal asymptote is y equals 4/3. Okay, so those are your three possibilities, and you can see it already feels like a lot to keep track of, which is why I'm telling you that cheat sheet should probably be something that that you have readily available to you. So let's look at some examples here. Okay, so here's the first example. Now, I made it so that the directions on these are always going to be the same, so you should be looking at the word or words point discontinuity and wondering what the heck that means, and that's because we haven't talked about that yet. But I wanted to make the directions all the same because we're always going to be looking for those different things. Okay? And we're also going to talk later about oblique asymptotes. So the setup on these for your answer, actually, let me go back. You should always start with point discontinuity, vertical asymptotes, horizontal asymptotes, oblique asymptotes. That's basically going to be your setup on all of these, even though we have not talked about point discontinuity and oblique asymptotes yet. So at this point, because we haven't talked about them, there's none for both of those. Okay, but I just want to get used to having that setup. As far as vertical asymptotes go, all we got to do on those is figure out where would the denominator equal 0. So if x equals -1, then our denominator would be -1 plus 1, which is 0. So that should be pretty quick and easy. The horizontal asymptotes, again, if you would reference your cheat sheet, this falls under the first bullet point. The degree of a of x is greater than the degree of b of x, because the degree of a of x is 3 and the degree of b of x is just 1. That looks pretty similar to the example I gave actually. So in this case, it says there is no horizontal asymptote, so none. So on this first one, that is all you needed, and that would be what the graph would look like. You could see a vertical asymptote roughly where x would be -1, right? And it's a pretty weird looking graph, obviously. Okay? Next possibility. So again, we'll get this set up. And these will again be none. I drew over that sign. Okay, so vertical asymptote should be x equals 3 because that's where the denominator would be 0. Horizontal asymptote. So if you look at your bullet points again, this is the third one. Their degrees are equal. The degree of the numerator is 1. The degree of the denominator is 1. So it tells us to divide their leading coefficients. So their leading coefficients are 2 and an invisible 1. So 2 over 1 is 2. So the horizontal asymptote would be y equals 2 on this one. Okay. And I wanted to show you what the graphs look like on these other ones as well. So I just typed them all into y equals on my calculator. So if I hit graph, yeah, so that one would look like this. So you could see a horizontal asymptote running where y would equal 2, right? Basically 2 above the x-axis, and a vertical asymptote where x equals 3 to the right of the y-axis. So you can see that one. Let me just go back. We'll get ready for the second one, or third one technically. Okay. Yeah, so we're here. All right, so again, we'll do our setup. PD's point discontinuity. I know that you see that up there, and I mentioned it, but just so you understand what that means. And again, OA is oblique asymptote. So again, for now, none on both of these. Vertical asymptote in this case is just going to be x equals 0, because if it's 7x squared, if you put a 0 in for x, 0 squared is 0, 7 times 0 is 0. Horizontal asymptote, referencing the chart. Okay, in this case, the degree of our numerator is less than the degree of our denominator. So that's the second bullet point. If the degree of a of x is less than the degree of b of x, the horizontal asymptote is the line y equals 0. So y equals 0. So that would be what we would want on this one. And if I check out the graph here, yeah, so both of those are basically hugging the two axes, the x-axis and the y-axis. So that kind of makes sense. And let's get the third one loaded up. Okay. All right, same thing. PD, BA, HA, OA. None and none for now. Okay, on this one I would say horizontal asymptote is probably easier. It's clear that the degree of a of x is less than the degree of b of x, right? So that means, just like last time, it's just y equals 0. The vertical asymptote, we have to figure out where the denominator is 0, so this is kind of like the bell ringer. We're going to have to take x squared minus 3x minus 4, and we're going to have to factor it, and it looks like x minus 4, x plus 1, so x equals 4, x equals negative 1. So the reason I put this one in there is you can have multiple asymptotes of any given type. I guess for us right now it's mostly, or it's I guess only going to be vertical asymptotes, because the others don't really leave us much of a possibility for multiple. But again, if I go over to the calculator, hit graph on this, yeah, so one of the examples on that graphic that's on your cheat sheet look kind of like this. You could see how there would be two vertical asymptotes there. So just wanted to show you one like that so that you don't get confused when you see it later on. I think what I might do is make a separate video here, just because I think my videos are not to exceed 20 minutes. So instead of exceeding 20 minutes, I'm just going to end this one right here. It'll be its own video, and then you can jump back into, I guess it'll be called E4 Part 2 or something like that. So see you in a minute, I guess.